So we previously just looked at what uncertainty means. If you're still confused at this point, pause the video, make sure to click the link above to take a quick tour of what uncertainty means in a chemistry lab. Now we're going to take a look at different examples of uncertainties. From last time, we've seen uncertainties in measurements of beakers, graduated cylinders, and volumetric pipettes. If I were to measure 25 milliliters of liquid, they would have different uncertainty measurements for all of them. We could see that the values increase in accuracy and precision as we become more confident with our measurements using different types of glassware. We could see that a volumetric pipette's uncertainty is 100 times less than a beaker. So we are more confident about our measurement using a volumetric pipette than we are with a beaker. Now let's take a look at a different volumetric pipette. See, I'm using a different one by a different company. And the volumetric pipette that I use, I'm not completely certain with. So again, this is our volumetric pipette. So say we're not very certain about our measurement, but a volumetric pipette is accurate up until the hundredths decimal. So if I were to measure 25 milliliters using this 25 milliliter volumetric pipette, say my uncertainty will then be plus or minus 0.02 milliliters. This means that 25 milliliters that I'm uncertain about, I'm either uncertain about it being less, so maybe I measured it a little bit less than 25, or I measured it a little bit more than 25. So this tells me that my measurements, I have to have a range of confidence. So how much am I not sure about? So that is my uncertainty. The uncertainty that I determined for this volumetric pipette was plus or minus 0.02. So it could either be above 25 by 0.02 or below 25 by 0.02. Similarly, let's say we were trying to make a solution of salt water. So we needed to measure some salt using an electronic mass balance. And measuring 2.87 grams of salt, this gives us a value of up until the accuracy of the hundredths. So this means my uncertainty would have to go to the hundredths. So I set it as plus or minus 0.02 because I feel like the electronic balance is probably pretty accurate. So I'm not going to make it greater than 0.02 grams for my uncertainty. If I use a beaker and I put my salt into a volume of distilled water, say that volume is 32 milliliters of water. The beaker is accurate to the ones place, so not as accurate as a volumetric pipette, remember from before. So the uncertainty for this would have to be reported to the ones place. So in this case, I set it as plus or minus 2 milliliters.